Hey Algebra 1, this is going to be your properties of exponents review test. So it's going to get started with the first one. You're going to simplify each of the following without negative or zero exponents. This first one is going to be where you're distributing the 2 to everything on the inside of your parentheses. So you have 3 to the second, which is equal to 9. I'm going to go ahead and do that real quick. And then y to the 6 times 2 would be y to the 12. Everything else is going to stay the same. So you're going to have x to the 5th times y to the 2nd times a z. Then you can add your same bases. The only ones we can add together are the y's. So you should have 9 x to the 5th, y to the 14th, and then times z. If you had x, y, z out of order, that's fine, but normally you want to try to keep it in alphabetical order. For number 2, again, you're going to be distributing the 3 to everything inside the parentheses. So 4 to the 3rd power is 64. D to the 3rd times another 3 is d to the 9th over c to the 5th times c to the 3rd is c to the 15th. We can't simplify anything else there, so this would be your final answer for number 2. For number 3, it doesn't look like you're distributing anything, so you're just basically combining your like bases and multiplying your whole numbers. I'm going to go ahead and multiply this negative 3 times 6, which is negative 18. I can also put the a's together. A to the 2nd times a to the 1st would be a to the 3rd. B to the 1st times b to the 4th would be b to the 5th. And then I just have a c left over, so this would be your final answer for number 3. Number 4, we have a 0 exponent, and anything that's 0 to the exponent except for 0 itself is always equal to 1. So in this case, we'd have 7 over 1, which is just equal to 7 for number 4. Number 5, let's go ahead and just combine what we can here, noticing that we have 2 negative exponents. What we can maybe do first is just go ahead and add them together. If we added them together and multiplied, we would get negative a to the negative 9th power, which we can rewrite as negative 1 over a to the 9th power. You might have figured it out a different way, and that is totally fine as long as you get negative 1 over a to the 9th. For number 6, we have 2 negative exponents. I'm just going to basically switch their places. So I'll have 5 with the w to the negative 4th on the bottom. I also had previously a w to the 2nd, and then x to the negative 2nd is just going to go on top. So this is what I had originally. And then I can go ahead and combine the w's at the bottom. So I get 5x to the 2nd on the top over w to the 6th power. For number 7, this one, you don't necessarily know what a and b are, but the rule does say if you have the same base, you're supposed to add your exponents. So you could show 10 to the a plus b, and that would be how you would show your answer for number 7. For number 8, we have a lot of things to distribute here. So what I'm going to do first is go ahead and maybe, instead of distributing the 2 at first, I'm going to go ahead and actually simplify the d bases and the f bases. So what that looks like is I would have d to the 5th power, because I did 11 minus 6, and then f to the 10th power, because I did 16 minus 6, and then that's still to the 2nd power. So I worked out whatever was in the parentheses first. Then I distributed, so I got d to the 10th times f to the 20th. You still maybe have gotten that, you just might have dealt with bigger numbers, and that is okay. Number 9, both of these are negative exponents. You can go ahead and combine them first. You would get negative x still, because you're multiplying a negative times a positive, to the negative 5th power, because that's negative 2 plus negative 3. And then to make that a positive exponent, we would just put that on the bottom, so we would get negative 1 over x to the 5th as our final answer for number 9. For number 10, we have kind of a combination here. We've got some positive exponents, some negative exponents, and then we've got some things that we need to combine together. First thing I'm going to do is combine whatever's on the top. So I'm going to do 2 times 3, which is 6, and a to the 3rd and a to the 5th would be a to the 8th, just to get that simplest form up top so I don't have too much to deal with. And then I have this a to the negative 2nd on the bottom, Well, that is originally going to go back up to the top with a to the 8th. So when I have two of the bases that are the same thing, I'm going to get 6a to the 10th power. For 11, I'm going to distribute everything here. So negative 15 to the second power is a positive 225. H to the 9th would be h to the 18th, and k to the 7th would be k to the 14th power. Here's my final answer for number 11. For number 12, it looks like I have a few different things I could try here. Notice I do have two y's that I can cancel out, or y minus y would just equal nothing. So if you wanted to, you could cancel those out, and you would essentially be left with 2 to the 3rd power, or an 8 here. Okay. The reason is because you can cancel out these 2's, and you're still left with 2 to the 3rd over that. For number 13, we have distribution we would need to do on both parts. What I would do first is maybe distribute what's in the brackets first. So c to the 5th and p to the 4th will stay the same. And then here on the bottom I'll have c to the 2nd and p to the 2nd, all to the 3rd power. And then what I'm going to do is go ahead and simplify what's inside the brackets. So c to the 5th over c to the 2nd is c to the 3rd, and p to the 4th over p to the 2nd is p to the 2nd. And then I'm going to take that to the 3rd power. So I should get c to the 9th and p to the 6th. Okay. For 14, I can also distribute here. Something to keep in mind whenever you are getting a negative number to be negative, it'd be like negative y to the 32nd power. Because you're multiplying even numbers, you don't need to keep the negative. So you would actually just have y to the 32nd power, and then d to the 48th power. Or you could have it switched around, d to the 48th power times y to the 32nd. So either one of these would work. For number 15, we would have both your y's would essentially go on the bottom to get rid of this negative exponent. So y to the 2nd and y to the 6th will be on the bottom, and that's going to give you 1 over y to the 8th. Okay, let's go ahead and flip the page. Looking at number 16, we have m to the 5th times m to the negative 2nd. That one is going to give us m to the 5th over m to the 2nd, which is equal to m to the 3rd. Or you could have just added 5 plus negative 2 and automatically gotten your 3. 17, we're looking at simplifying both the numbers and the letter m. This negative 40 and positive 20 can be simplified to be a negative 2. And then the m to the 6th and the m to the 3rd, you're just subtracting your exponents to get m to the 3rd. So negative 2 times m to the 3rd for 17. 18, we have a lot of things we can combine here. What I did first is combined my 2's. So negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And then I did x's. So I have x to the 2nd times another x. That'd be x to the 3rd. I'm going to cross these off as I go so I can not use them again. I'm also going to keep it in alphabetical order, so I'm going to do the y's next. So I have y to the 2nd times another y. That's also y to the 3rd. And then I have 1, 2, 3 z's. So z to the 3rd. So everybody gets a 3rd power. Yay. For number 19, again, I'm going to go ahead and multiply 11 times negative 10. That is negative 110. And then I can multiply the c's. C to the 8th and c to the 4th is c to the 12th. And then d was all by itself, so it doesn't have to be added with anything. 20a starts our scientific notation. This one should be 2.51 times 10 to the 5th power. Because if your decimal's here at 2.51, you scoot it 1, 2, 3, 4, 5. Same thing for 20b. You have 9.4 as your ideal decimal, and you had to scoot it 1, 2, 3, 4 times to the left, so that's 10 to the negative 4th power. For 21a, you're writing this in scientific notation, so you're taking the number 5.2 and moving it 7 times to the right, or a 52 with 6 zeros behind it. or 52 million. Same thing for 21b, take 9.07 and move it 3 times to the left, so it'll be 0.00907. For each one of these, it says perform each computation and write your answers in scientific notation. The first one I just did 6 times 2, which is 12, and then 10 to the 4th times 10 to the 5th is 10 to the 9th. But 12 cannot represent scientific notation, so I need an extra decimal place, which means this 10 to the 9th will raise 10 to the 10th, and then I can make it a 1.2. So my answer for number 22 should be 1.2 times 10 to the 10th power. For 23, I'm just adding. So what I did here is I actually just wrote it in standard form and then added it together. So this is what my work looks like. So I get 120 million, and then I'm just going to write that in scientific notation, which would be 1.2 times 10 to the 8th power. Or you might have gotten 12 times 10 to the 7th, and then just raised your exponent to get your decimal place ideal. For number 24, you're dividing. The first thing I did, though, was take care of what was on top. So I actually did 8 times 6, which was 48, and 10 to the 2nd times 10 to the 12th, which was, or 10 to the 2nd, which was 10 to the 12th. And then still kept it as 2 over 10 to the 8th. And then I divided, so I got 24 times 10 to the 4th, because I subtracted my exponents. And I know I need my number between 1 but still less than 10, so I changed my 24 to 2.4 and my exponent to be the 5th to the 5th power. Same kind of thing for 25. I divided first, so I have 6 divided by 2, which is 3, and then subtracted my exponents. I got 10 to the 3rd power. No need to raise my exponents there. So I would be done with that one. That is going to conclude our review. Thanks so much for tuning in, and good luck on your test.